In the expression that we had in the previous example, we had an expression similar to this one. It's just that on the right hand side we used 9 instead of 4. And mathematically, there are many ways in which you can find the value of x. It's just that in the previous expression I used the method that I felt was the simplest method to find the value of x. So one of the biggest concerns that I got in the previous example was that why didn't I square both sides like this in order for me to remove the first square root. And then if we use this method for an example, we are going to have x, the square root of x, square root of x is equal to 4 to the power of 2 as the next step. Now the concern that I had with this method is that it is going to be lengthier and is going to require the application of various exponential rules to a point where it may be easy along the way to make mistakes. But if you choose to use this methodology or approach, you have to understand that if you're gonna do the same, let's say for instance you want to apply the same approach of raising everything to the power of 2 and then to the power of 2, you must understand that we only use this method to get rid of the square root. And the moment we begin to have something outside the square root, we need to make sure that whatever we have outside the square root has to go to the right hand side. So in order for us to successfully apply the method of squaring both sides to get rid of the square root, first of all in this stage we are going to divide both sides by x so that we don't have x on the left hand side, which is outside this square root that we are trying to eliminate. So we are going to come here on the left hand side and say this is divided by x and this is divided by x, so that on the left hand side we are only left with the numbers or expressions that are located within the square root, this square root, and that we are trying to eliminate by squaring both sides. So this x is going to cancel with this x, and then we're going to be left with the square root of x, and the square root of x is equal to 4 to the power of 2 divided by x. Now the next step is going to be to square both sides and square the right hand side as well. So this 2 and this square root is going to cancel each other, and then we're going to be left with x multiplied by the square root of x, which is whatever we have within the brackets, is equal to 4 to the power of 2 multiplied by the square root of 2 is going to give us 4 to the power of 4 divided by x multiplied by the power of 2 is going to give us x to the power of 2. On the left hand side, before we apply the idea or the method of squaring both sides to get rid of this square root, we must make sure that the left hand side only consists of x, which is within the square root. So now we have got x which is outside the square root. We divide both sides by x. It's either you're going to use this division, which is going to create a complex fraction, or use this division that is going to simplify things. So this x is going to cancel with this x, and then you're going to be left with the square root of x, and then this is equal to, remember this is basically x over 1, and then we can change the division into multiplication in as much as we change the denominator to be a numerator and the numerator to be a denominator. So this is going to be 4 to the power of 4 divided by x to the power of 2 multiplied by 1 over x. And this is going to give us 4 to the power of 4 is going to remain as is because it is being multiplied by 1 and then divided by x multiplied by x squared is going to give us x to the power of 3. The bases are the same. We add the exponent. This is the power of 2. This is the power of 1. So in the end, we are going to have the square root of x is equal to 4 to the power of 4 divided by x to the power of 3. Now at this stage, you'll realize that the x that we have is only found within the square root. So we can just simply square both sides and raise this to the power of 2, and then this is going to cancel each other, and then we're going to be left with x is equal to 4 to the power of 4 multiplied by the power of 2. 4 multiplied by 2 is going to give us 8. This is going to be 4 to the power of 8 divided by 3 multiplied by 2 is going to give us 6. So this is going to be x is equal to 4 to the power of 8 divided by x to the power of 6. 4 to the power of 8 and x to the power of 6 cannot divide each other since they are not like terms. So we do cross multiplication, where x is going to be multiplied with x to the power of 6. 1 is going to be multiplied with 4 to the power of 8. So in the left hand side, we are going to have x multiplied by x to the power of 6 is equal to 4 to the power of 8 multiplied by 1. So this is just going to remain as 4 to the power of 8. So on the left hand side, the bases are the same. We add the exponents. 1 plus 6 is going to give us 7. So we're going to take one base and then added exponents is equal to 4 to the power of 8. But we want to find the value of x. So the only way to do that is to multiply the left hand side and the right hand side, or with the reciprocal of the exponent of x. So this is 7 over 1, and therefore the reciprocal is going to be 1 over 7. We do the same here. So this is going to be multiplied by 1 over 7. So 7 multiplied by 1 is 7. 1 multiplied by 7 is 7. 7 divided by 7 is going to give you 1. So 1x to the power of 1 is the same as x. And this is equal to 4. 8 multiplied by 1 is going to give you 8. And then 1 multiplied by 7 is going to give you 7. So in the end, we are going to have 4 to the power 8 over 7. And another concern that was brought forth was that I have to simplify this further, or simplify this whole expression fully. So if you use your calculator, you realize that your x will be equal to 4.876. Rounded off to 2 decimal digits is going to be 4.88. Now, as you may have noticed, the method of finding the value of x through squaring of both sides, the left and the right hand side, appears to be longer, even though we happen to get to the answer that we're looking for. So the method that I used in the previous example involved simplifying whatever we have from the innermost square root. So what we do basically is to convert the square root of x into x to the power of half. So that means that our expression is going to be x, the square root of x, multiplied by the square root of x is going to be replaced by x to the power of 1 over 2. So this is going to be x to the power 1 over 2 is equal to 4. So in the end, within this square root, we have established the same basis. So if we are multiplying the same basis, we add their exponent. So we are going to say 1 plus 1 over 2. And if you work it out, it is going to give you 3 over 2. So in the end, within the square root, this square root, you are going to have x to the power 3 over 2. And that means that the next step will just be x, the square root of x to the power 3 over 2 is equal to 4. Now the next step will be to get rid of the square root, and we do that by erasing the expression that we have within that square root to the power of half. So our next expression will read the square root of x multiplied by x to the power 3 over 2 all into the power of half is equal to 4. 1 multiplied by 3 is going to give us 3, and then 2 multiplied by 2 is going to give us 4. So in the end, we are going to have x to the power 3 over 4, and therefore our next expression will be x, this x multiplied by x to the power 3 over 4 is equal to 4. So the next thing will be to simplify whatever we have within the square root. So we have got the same bases that are multiplying each other. We add their exponents. So 1 plus 3 over 4. So this is going to give you, the square root of x to the power 7 over 4 is equal to 4. Now at this step, you can either square both sides or convert the square root into the power of half, and then you multiply that half with the exponent of x. So either way, you are still going to get into the same answer. So here we are going to say x to the power 7 over 4 multiplied by the exponent of half, which is representing the square root, is equal to 4. And then from there you will say 7 multiplied by 1 is going to give you 7. 4 multiplied by 2 is going to give you 8. So x to the power 7 over 8 is equal to 4. So since we are looking for the value of x, we're going to multiply the left hand side and the right hand side with the exponent, which is equivalent to the reciprocal of the exponent of x. So the exponent of x is 7 over 8, and therefore it has to be multiplied with 8 over 7. In other words, the numerator became the denominator and the denominator became the numerator. We do that in order for us to remove or get rid of our fractional exponent. 8 and 8 are going to cancel each other, 7 and 7 are going to cancel each other, and at the end of the day we're going to have x to the power of 1, which is basically x. And then we do the same here. This is to the power of 1 over 1 multiplied by 8 over 7. So 1 multiplied by 8 is 8, 1 multiplied by 7 is 7. So in the end we are going to have 4 to the power 8 over 7. So x will be equal to 4 to the power 8 over 7. And if you use your calculator, your x is going to be equal to 4 0.88 rounded to two decimal digits. Thanks for watching.